my name is Hannah, and I work for the Pacific Grove Museum of Natural History as the Limpets Program Coordinator. So Limpets is a long-term monitoring program where students go out and actually collect scientific data the exact same way that scientists do. And so there are two programs. We have our Sandy Beach program, which you're going to learn about a little bit today, where students collect data on the Pacific mole crab, Emerita analoga. And then we also have our Rocky Intertidal program, where students learn how to identify different algal and vertebrate species that you find in rocky intertidal habitats here in Monterey Bay. So I'm here on the coast. It is an absolutely gorgeous day here in Monterey Bay, and I'm just going to show you a little bit about how important these sand crabs are to the Sandy Beach ecosystems and how to find them, and show you a little bit about their anatomy. So first off, where do you find sand crabs? What part of the Sandy Beach are we talking about? So behind me, this is the area, I think where everybody loves to walk, right? When you come to the beach, you take your shoes off and you like to walk where the waves are coming up onto shore, right? So that wet, sandy area. So we actually call that area the swash zone. Students come out and they will actually use these cores, so kind of like clam diggers, to dig into the sand in order to find the crabs. So the thing about the swash zone is it doesn't stay in the same spot every day on the coast. So if some of you guys have come out here and you can see that a lot of the sand is exposed, right? And then sometimes you come out here and very little of the sand is exposed, right? The water comes up really high up onto shore. That's because of, you guessed it, the tides. So here in California, we have 2 high tides and 2 low tides every day here on the coast. So the swash zone is constantly moving up and down. So these sand crabs are very mobile animals. They're constantly going up onto the sand, right, as the water comes up, so they don't end up getting in deeper water where there's bigger predators, and then they have to move down the beach, right, as the tides recede out, right, as the tides go out. We call those the low tides. All right, so then they don't end up getting stuck, right, and exposed to the air and to the elements and to predators, and so they don't desiccate or dry out. So we're going to take a little walk down the swash zone to kind of make a couple observations to show you where prime sand crab habitat is, and hopefully we can find some and go over a little bit of their anatomy. All right, let's go, guys. As you can see here, you can see the differences between the wet sand and the dry sand, right? So as of right now, the tide is kind of receding back, so we're starting to get, as the tide goes out, all right? And so you can kind of indicate here where the top of the rack line is. So the rack line is where the highest tide that day has come up to. So as you guys can see right here, and you can kind of do a sand wetness test. So this sand is much wetter than, say, on this side here, right? So dry and wet sand. And then as you can see here, as a close-up, you can see a bunch of these things that look like dead sand crabs. But in fact, these are actually the sand crab molts. So sand crabs have exoskeletons, okay, they're crustaceans, so they have their backbone, their bones on the outside of their body, as opposed to humans like us who have it on the inside. And so in order for them to grow, they have to shed their exoskeletons in order to become larger. So a lot of times when people come to the swash zone area and look in the rack line, it looks like there's a lot of dead things, but again, it's just their molts. But this is a great indicator to show us that we're getting into the sand crab zone. All right, and so the thing is as students kind of make those observations, so we're looking at where we're getting into the wet sand area, we're seeing a lot of exoskeletons here, and then also another indicator is these little holes or bubbles. So those are also an indicator that there are sand crabs in this area. Okay. So the thing to remember is that even though we are in our sand crab habitat area, in the swash zone area, there are probably thousands, who knows, millions of sand crabs that are here in the swash zone area. But that doesn't mean once we find the swash zone that we're going to actually find sand crabs. So sand crabs are patchy in their distribution. So what does that mean? So that means that even though we know there are plenty of sand crabs, if we go out here, we could dig here all day in one certain spot and not find any. That's because sand crabs are going to be in groups. They're going to be in areas where the food is, and so sand crabs are filter feeders, so they actually have these specialized antennae, and they kind of look like a feather duster, and that they put out, and so they can filter in what is called plankton. Okay, so they're going to be where the food is. Also, safety in numbers, right? So if you're in a bigger group, it's less likely for you to get eaten. So a couple of predators that love to eat sand crabs are surf scoters, which is a type of bird, which there's actually some out here, I know you can't see, but they love to eat sand crabs. Also, surf perch fishes. So actually 90% of their diet consists of sand crabs. And then another big predator of sand crabs is, you guessed it, the lovely and wonderful southern sea otter. They love to eat sand crabs as well. So the bigger the group, the less likely they're going to be eaten. So they're very patchy in their distribution, so that's why when you look for sand crabs, you have to kind of go in a really big area and start searching for them, because once you find one, you're probably going to find a lot. Now you might be asking, why are sand crabs important? Why should we study them? And the answer is that sand crabs, and this particular species, Emerita analoga, has a wide distribution. So you can find sand crabs all the way from southern Alaska down to Baja California. So they have a wide distribution, and they encompass a lot of the invertebrate species that you find in sandy beach habitats here on the West Coast. So let's just say if we were able to take all of the invertebrates, other invertebrates that live here in the swash zone area, if we were able to collect all of them and weigh them, over 80% of that weight would just consist of sand crabs. So they're a great indicator species, because since you can find them everywhere along the West Coast here, and because they have such high numbers, they're great to let us know how the sandy beach habitats are doing. So if we're starting to go out and find less and less sand crabs in places that we should find many, that can let us know that something's going on, whether that's human caused, that could be an oil spill, could be a sewage spill, or it could be some natural phenomena. So it could be an El Nino year, so warming of sea surface temperatures, or other effects that are due to climate change. So they're a great way to let us know how these sandy beach habitats are doing. So if you give me just a second, I'm going to go look for some sand crabs, and let's see what we can find. Alright, hello everyone. So I went digging to look for a couple of Pacific mole crabs, and success, I actually found a few that I'd love to show you guys. So this is the Pacific mole crab, Emerita analoga. So maybe some of you guys that live here on the California coast have seen these guys before. They're not your typical looking crab. So you can only see 8 visible legs here, and they actually don't have any pinchers. But they get the name Pacific mole crab because they do just as a mole does. They burrow. So they have this specialized tail, all right, or we call telson, that they use as a shovel. So if you lift it up, it moves back and forth and acts like a shovel to help bury itself into the sand very quickly. So that's where it lives, in the swash zone, right? So it has to bury very quickly so it doesn't get washed out with the tides, and also so that way it's able to protect itself from predators. So it's about 3 to 4 seconds that it takes for them to burrow, so very, very quickly. And what they do is, once they actually burrow into the sand, they'll actually bring out these 2 secondary antennae which is basically their feeding antennae, and they look like little feather dusters. So they bring those out, and as they have their head sticking out of the sand, they filter out plankton, as I described before. That's their main food source, and so they'll catch any pieces of plankton or dead organic material, so things that come from other living things, to eat on. And when the students come out to measure and collect data on these, they actually measure the top part of the sand crab. So as you all can see right here, and I'll try to get a little bit closer in, this top shell is called the carapace. So students will measure from between the eye stalks down to right where the end of the carapace meets the telson, and they record that number in millimeters. And then they have to determine the gender. So if a sand crab, all right, this guy right here, if or she is 10 millimeters or smaller, it's considered a recruit or a juvenile sand crab. And so with those, we can't determine their gender just yet. They're too small. However, if they're 10 millimeters or larger, then we can find out whether they're male or female. So what they do is, they will pull back the telson, just like I did before, and they expose the abdomen. So if you can see here, all right, hopefully you can see here, to tell whether it's male or females have these things, and this is in fact a female, they have these things called pleopods. So if you can see right here, these little, what students like to call spaghetti legs, again, scientific name for it is pleopods, and they have these to help hold in their eggs. So if we were to open this one up and you would see this bunch of eggs there, which we call clutch, it would obviously be a female. But if there's no eggs, another way to determine is these pleopods. So that's how you determine whether it's a female. And for a male, all right, we make a couple other observations. And just to let you know, females are always much larger than males for this particular species. All right, so I actually do have a male here that I found. So let me see if I can get him out. All right, so as you can see here, he is much, much smaller than the female we just looked at. So if we kind of pull that back, you can actually see that he doesn't have those specialized swimming legs called pleopods, and it's a little bit hard to see, but he does not have them. So that's how you determine whether male or female, and that's what the data that the students collect for us for this particular program. So I actually found another female that actually has a clutch of eggs that I wanted to show you. So if I can find her real quick. So this is a clutch of eggs. So sand crabs can hold on average about 50,000 eggs per clutch. And as you can see here, hopefully you can see here, the color of this clutch kind of lets you know whether these eggs are ready to hatch or not. So you can see here that the eggs have a really bright orange color. That means that they haven't been fertilized yet, or they've just been fertilized. So it takes 1 month for these eggs to be ready to hatch. And so when they get to the almost hatching stage where they're going to be released into the water, they get a kind of brownish grayish color. So just by looking at the color, you know whether they're ready to be hatched or not. So again, I just wanted to show you that because especially here on the coast in Monterey, we're actually finding lots of these. So this is actually our breeding season. So there are a lot of females with eggs that you can find out here on the coast. And so I'm going to put her right back. Thank you all so much for joining me today. I hope you enjoyed it and that you have a better appreciation for the Pacific mole crab. Tune in next Tuesday. I will be doing another Explore Your Coast with Hannah segment, and I'm actually going to be doing a Pacific mole crab dissection so you can learn a little bit more about their anatomy and this parasite that actually lives in these sand crabs. And don't forget, the museum will be having digital lessons Monday through Saturday posted on the museum website on the Museum to You page. So make sure you check that out. Have a great day, everyone.